Man, that was a bit tough. We urgently had to structure this better. And the distribution box even has an added value on its own. Sometimes we like to share the mistakes that we made, and of course we also explain how to do it better. As you know, we built a lap counter ourselves that makes a lot of fun. Today we're talking about the related wiring of our slot car racetrack, which desperately needed a better structure. By the way, the distribution box is also interesting in case you don't use our DIY lap counter, because you can conveniently change the race direction or switch off the power manually to interrupt a race. This thing has a lot of features that we explained in the previous videos. I knew the wiring could get complicated. And that's why we created the circuit diagram, which I explained in previous episodes. The schematic is helpful, but we still made mistakes in wiring the switches, and it took us a lot of effort to find and fix them. Oops, we have a shortcut somewhere. We had that several times. It's always a good idea to work with the lowest voltage and with current limitation when we switch on for the first time. Our cabling has become quite confusing, and it's no surprise that we made mistakes. However, after we found and fixed all the errors, our racetrack is running really well. But if we want to rebuild the racetrack later, we will probably again need hours to get everything connected correctly. Smart people know it anyway. You're not failing on the big tasks, but on the small details. And our spaghetti wiring is such a detail. I'm trying to say that we urgently need to introduce a better structure for cabling. Actually, we should have done this when connecting our prototype, because we had already planned for it in the circuit diagram. This is how we found out the hard way how important this distribution box actually is. In addition, the box alone offers an added value, as you can easily interrupt the race or change the race direction. In principle, it's about introducing interfaces in the right place. We want the complicated wiring remaining in a junction box when you dismantle the racetrack. We are installing the two 4-way switches into this box, and they are looking like this from the side. Switch 1 bypasses the relays of our lap counter, and switch 2 changes the race direction. The 12 clamping screws each are the connections for our two switches. Our interfaces we can implement, for example, using banana plugs or connection terminals. We need connections for the power supply, the two speed controllers, and 2 × 2 outputs to the power trails of the model racetrack. As mentioned earlier, the two tracks must not have a common ground. Next, we have the connections for the two relays that are controlled by the lap counter. The picture shows the non-active state of the relays. When the two relays are active, the power to the tracks is disconnected. In addition, the track is short-circuited in this state, so that the dynamic brake of the racing cars takes effect. I'm explaining this in case you're wondering why we need both the normally open and the normally closed contacts of the relays. And then we have the connections for the voltage sensors. As you know, the voltages are displayed on the browser interface of our lap counter, and we use the voltage information to determine penalty times, among other things. New features that we are not revealing yet are also based on that. It is worth watching the earlier episodes on the topic, because there we explain the functions, structure, code, housing and much more. Now let's talk about the wiring in the box. Since the cables in the distribution box are short, we don't actually need to use those thick cables that we saw in the pictures earlier. 0.75 mm square installation cable is sufficient. By the way, it is very helpful to use 5 different colors for the cables in order to keep the overview. First, we make all ground connections in blue. The red cables are going to the power supply. Next, we connect the tracks with orange cables. Then we connect control 1 with a yellow and a green cable in this way. For control 2 we do it accordingly. Then we connect the 2 switches and the connections for the voltage measurement with green cables. First for track 1 and then for track 2 accordingly. Our distribution box is now finished, and I can already see that a 3D printed housing would be nice for it. Let's see, maybe I will design one. As I said, always work with low current and low voltage when switching on for the first time. Before you start your first race, you should test whether track 1 and track 2 correspond to the lab display and the voltage display on your browser interface. Possibly you need to swap the outputs for the tracks or the connections for the voltage measurement or for the relays. We urgently needed a better structure to keep track. With the distribution box, setting up and dismantling the model racetrack is easy to handle. The box could be even improved further. I'm thinking of indicator lights, a voltmeter and an ampere meter. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.